So good evening, student. Today I will be discussing alkynes. So like alkenes, alkynes are also unsaturated hydrocarbons. Unsaturated hydrocarbons. So unsaturated hydrocarbon means carbon-carbon double bond or triple bonds are present. So here we find that carbon-carbon triple bonds are present. So the general formula of alkyne is CnH2n minus 2. It contains 4 hydrogen less than alkane and 2 hydrogen less than alkene. So keep in mind that a triple bond is made up of 2 pi bond and 1 sigma bond. So single bond is sigma bond, a double bond is 1 pi 1 sigma, a triple bond is 2 pi 1 sigma. So keep this in mind. Alkanes belong to saturated hydrocarbons, alkenes and alkynes belong to unsaturated hydrocarbons. So this is the general formula. So first member C. So C, so it is not possible. So n equal to 2 is starts. So C2H2. Its common name is acetylene. Its common name is acetylene. Opaque name is ethyne. Opaque name is ethyne. So it is called ethyne. So ethyne has 2 pi bond and 3 sigma bond. So keep this in mind. Ethyne has 2 pi bond and 3 sigma bond. It is sp hybridized linear structure and the bond angle is 180 degree. The bond angle is 180 degree. So keep in mind the hybridization is sp with 50% s character. So once the s character is more, so higher the percentage s character, more is the electronegativity, and more is the acidic strength. So more is the acidic strength. So alkynes are highly acidic. So out of alkynes, alkenes and alkanes, alkynes are the most acidic. So more is the acidic strength. So keep this in mind. Now also keep in mind, this is important for your exam student. C2H6 is ethane, C2H4 is ethane, C2H2 is ethyne. So this is ethane, this is ethene, this is ethyne. So ethane has sp3 hybridized, ethene is sp2 hybridized, and ethyne has sp hybridized. So here percentage as character is 25% in alkanes, almost 33% in alkenes, and 50% in alkynes. So if you see the pKa value, it is like 50 for this, 44 for alkene, and 25 for alkynes. So lower the pKa, remember, lower the pKa value, stronger the acid. Lower the pKa values, stronger is the acid. Longer the pKa value, stronger is the pKa. pKa you have read in ionic equilibrium, it is equal to minus log Ka. So higher the Ka, stronger the acid, lower the pKa, stronger the acid. Keep this in mind. A small or lower pKa value means that the acid is very, very strong. The acid is very, very strong. So keep this in mind. So alkynes are more acidic than alkene, alkene are more acidic than alkane. That is reflected in their pKa value. So you can see 50, this is 25, this is 44. So lower pKa value means stronger acid. Like one of the strongest acid known is superacid HbF6 with a pKa value of minus 12. It is regarded as superacid, one of the strongest acid known. Acetylene, the first member of alkyne, is used for arc welding purpose. In the form of oxyacetylene torch. Oxyacetylene torch. So it is used for arc welding. Acetylene, that is the common CH, triple bond CH, also written as C2H2. So when acetylene is mixed with oxygen gas, It is used for arc welding purpose, that is oxyacetylene torch, because it releases a huge amount of energy. Now we will discuss nomenclature. So the suffix that you will use is "-ine". Like if you have CH triple bond C CH3, so it has 3 carbons, so it is called propyne. Second molecule. The priority is given to triple bond, so it will be 1, 2, 3, 4, 5. So 5 carbon is, it is called pentyne. Pent 1-ine. Why we need to give one position? Because this triple bond can be here also. So they will have different names. So pent 1-ine. Look at this molecule. This molecule has a double bond on second number carbon, so it is called pent 2-ine. Now this 1, 2, 3, 4. So this 2 number is methyl group. So 2 methyl. So it is called 2 methyl. So not 2 methyl. You have to give priority to triple bond. So you don't have to write like this. You have to write from this side because the triple bond is this. So 1, 2, 3, 4. So 3 position is methyl. So 3 methyl but 1-ine. So if you write from this direction, then that will be wrong. So because you have to give priority to triple bond and then to substituent. So 1, 2, 3, 4. So the triple bond is first position and methyl is 3. So 3 methyl but 1-ine. This way we write the nomenclature of alkynes. So note down everyone.
Noted, sir.
Now, keep in mind that you have already read this question was asked in IIT Advanced. So they asked carbon-carbon single bond length 1.54 angstrom, carbon-carbon double bond 1.34 angstrom, carbon-carbon triple bond 1.19 or 1.20 angstrom. And they also asked carbon-carbon bond length in benzene, which has a bond order of 1.5, 1.39 angstrom. So this is in benzene, this is in alkane, this is in alkyne, this is in alkene, and this is in alkane. So this was asked in IIT Advanced. So keep this in mind. These data are important for your exam. So if you see the structure of triple bond, it will be like this. First, sp hybridized carbon. This is carbon. And this is the hydrogen, 2 hydrogen. Now, this is sigma bond that is formed. So this is 1s sigma. This is also sigma bond. This is also sigma. Now, how the pi bonds are formed. So we will see the pi bonds. So if you see carbon, this is the orbital. So what happens? These overlaps, these two overlaps. So these give rise to pi. And then these overlaps. This is also pi. So these two pi bonds are formed. This is 2px, this is 2py, 2px, 2py. So keep in mind that when 2pz overlap is 2pz, sigma bond is formed, but 2px overlap will give you pi bond. 2py overlap will give you pi bond. So keep this in mind. So carbon-carbon triple bond strength is very high, 23 kilojoule per mole. This is the bond strength, bond energy. Carbon-carbon double bond is 681, whereas carbon-carbon single bond is 348. So you have to keep this in mind. These data are important for your exam. So ethyne, we see that ethyne is a linear molecule. Ethyne is a linear molecule, as I have discussed this before. Ethyne is a linear molecule. So this is sigma overlap. And this is pi overlap. So sigma is a stronger bond, pi bond is a weaker bond. Copied?
No, sir.
Now we will discuss methods of preparation.
Done, sir.
First, we will discuss the method from calcium carbide. So keep this in mind that when CaCO3 is heated, it forms calcium oxide plus CO2. So thermal decomposition of calcium chloride gives calcium oxide. Now this calcium oxide is heated with coke to form calcium carbide plus CO. This calcium carbide, keep this in mind, this has been asked in all entrance exam. This is the carbide ion. So this has 2 pi 1 sigma. So many students get confused that has 3 sigma. No, it has 1 sigma 2 pi. So this has been question of IIT, another entrance exam. Now when calcium carbide is treated with water, it forms calcium hydroxide plus acetylene. So this is calcium carbide. When calcium carbide is treated with water, it forms calcium hydroxide plus acetylene or ethyne. Second method is from vicinal dihalides. If you treat 1,2-dibromethane, this is vicinal means the halide groups are on adjacent carbon. 1,2-dibromethane, in presence of alcoholic KOH, it will undergo elimination reaction. It is called dehydrohalogenation reaction to form now this is treated with sodium amide. Now when it is treated with sodium amide, it forms ethyne. So here sodium ion takes away bromine and NH2 takes away hydrogen. So it forms ethyne, which is our product here. So this base actually abstract a proton from here. So if it abstracts a proton, then here a negative charge will come. So this will come here and this will get removed. So this way it will form CHBr double bond CH2. Now this will be treated with sodium amide. So this amide ion will abstract a proton from here because this is suppose alpha carbon, this is beta, so it will abstract a proton from here, then this bromine will come out. So this will form acetylene. So this is where it happens. Understood?
Yes, sir.
Now we will discuss physical properties. So first three members are gases. Next 8 members are liquids. Higher members are solids. As I have told you, as the molecular mass increases, substance goes from solid to liquid to from gas to liquid to solid. All alkynes are colorless. All alkynes are colorless. Ethyne has characteristic order. Due to presence of phosphine, hydrogen sulfide, etc. So it has a garlic-like smell. Other members are odorless. Other members are odorless. Alkynes are weakly polar in nature. Alkynes are weakly polar in nature. So first 3 members are gases. Next 8 members are liquid. Higher members are solids. Alkynes are colorless. Ethyne has characteristic order due to presence of phosphine, hydrogen sulfides. Other members are odorless. Alkyne weakly polar in nature. They are lighter than water. They are lighter than water. They are also insoluble in water, but they are soluble in organic solvent. They are insoluble in water. They are soluble in organic solvent. Soluble in organic solvent. Like ethers, carbon tetrachloride, benzene, etc. So these are organic solvents where they are freely soluble or soluble. Their melting point, boiling point, and density increase increase in molar mass. Increase in molar mass. So their melting point, boiling point, density, they show gradation with increase in molar mass. So as the molar mass increases, these properties also increase. They are lighter than water. Keep this in mind. They are insoluble in water, soluble in organic solvents.
Copied, sir.
Now we are going to discuss chemical properties, and first we will start with acidic properties, chemical properties. So acidic character of alkyne. I have given you a little bit previous only, acidic character of alkynes. Sodium amide, strong base. Now what does a base do? A base accepts a proton. Even sodium is a strong base, it will react with hydrogen to form sodium hydride, metallic hydride. So sodium react with ethyne to form sodium acetylide plus hydrogen gas. This reaction suggests that ethynes are acidic in nature because it is giving proton to sodium. It is releasing proton. So ethyne is acidic in nature. Because ethyne, if you see the ethyne structure, it releases proton. So CH triple bond C minus plus H plus. So it is releasing protons. So acids are proton donor. So ethyne has sp hybridized carbon. Sp hybridized carbon means 50% S character. 50% S character means electronegativity is more, so it pulls the electron of proton. So proton comes out as H plus. Pulls out the electron of hydrogen, so hydrogen comes out as H plus. H plus is called proton in entire chemistry.
Copied, sir.
So this compound is called monosodium ethanide. Monosodium ethanide. Another molecule can react with this. So it can form disodium ethanide. It is called disodium ethanide. Even acetylene can react with sodium amide also. So this will take away protons, so it will form ammonia, and the sodium will come here. So this is sodium ethanide, also called sodium acetylide. So keep in mind that terminal alkynes are acidic in nature, because terminal alkynes, they can easily give proton. But if you have a alkene which is not terminal, then it is not acidic. This is non-terminal alkyne, this is terminal alkyne. So terminal alkynes are acidic. Terminal alkynes means the alkyne having the terminal position triple bond. That you have to remember. So acidic nature, remember, I have already discussed this. Ethyne will be more acidic than ethene. Ethene will be more acidic than ethane. presence of more alkyl group will reduce the acidic strength. So ethyne will be more acidic than propyne, because propyne has this methyl group which is plus I group. So plus I group decreases acidic strength. Butene will even be less acidic because it has 2 plus I group. So this way you have to decide the acidic strength. So this is important question for you all.
Noted, sir.
Now we will discuss few reactions. So the most important reaction is addition reaction. Addition reaction. So H2 they can add HX, they can add X2. So this can be added easily across triple bond. So what you need to do, if suppose HZ is a species is to be added, here Z can be H, here Z can be X, or here. So what will happen? It will be donating, the pi electron will be donating H electron, so a hydrogen, and it will shift. So it will be added across it. So it will form a vinyl cation. It is called vinyl cation. Now vinyl cation will be attacked by this nucleophile Z minus to form the addition product, which can further react. Now addition in unsymmetrical alkynes take place according to Markovnikov's rule. So most of the majority of the reaction of alkynes are example of electrophilic addition reactions. So keep this in mind, student. Now we will discuss second reaction, that is addition of hydrogen. So very well you know these reactions. You have read in alkenes also. So alkynes, when it is added with hydrogen in presence of platinum, palladium, nickel catalyst, with nickel the reaction is heated, but in platinum, palladium case the reaction occurs at room temperature, so it forms ethene. Now ethene further reacts with the in presence of this catalyst, so this will form ethane. So this you see that from sp it forms sp2, and from sp2 it forms sp3. That is, this is an example of addition reaction. This is an example of addition reaction. So if you have propyne, treated with hydrogen in presence of same catalyst, it will form propene. So first step, propene. Propene can further react with hydrogen in presence of these catalysts to form propane. So this is example of addition reaction. So from propyne, it forms propene, and from propene it forms propane. Easy?
Yes, sir.
Now we will discuss addition of halogens. Third reaction. Addition of halogens. Suppose if we take propyne and treat it with Br2, it forms CH3CBr double bond CHBr. It is called 1,2-dibromopropane. Now, this 1,2-dibromopropane can further react with Br2 to form 1,1,2,2 tetrabromopropane. So it is 1,1,2,2 tetrabromopropane. So you will write the nomenclature like 1, 2, 3. So longest carbon is 3. So one position has 2 bromine, 2 position has 2 bromine. So 1,1,2,2 tetrabromopropane. Fourth is addition of. Now this reaction discharges the color of bromine. So this is used as a test of unsaturation. This reaction you have read in alkenes also. So this is test of unsaturation. The product, the color of reddish brown color of solution of bromine in carbon tetrachloride is discharged. Addition of HX, hydrogen halide. So it forms geminal dihalide. Geminal means both the bromine group is on the same one carbon. So it is called 1,1-dibromoethane.
Noted, sir.
Now we are going to discuss addition of water. This is very important reaction. Addition of water. So ethyne reacts with water in presence of HgSO4, H2SO4. This reaction occurred at 333 Kelvin. Now what happens? This bond, this pi bond breaks. Here get negative charge. Here get a positive charge. So water, you know, H plus and OH minus. So here OH minus will act, here H plus. So it will become CHOH, CH2. Now this is vinyl alcohol. This undergo tautomerism. This undergo tautomerism to form ethanol. This undergo tautomerism to form ethanol. If you want to know how tautomerism acts, so let me explain you the tautomeric part. So write OH as like this. So this shift here, this shift here, this shift here, and this proton gets converted to here. So this will form a double bond, C double bond O, and here is H, and this single bond it will be converted. So it is actually enol form, and this is keto form. So keto enol tautomerism. This is called keto enol tautomerism. So this is a very important reaction. This reaction is also called Kucherov's reaction. So in case of ethyne, aldehyde is formed. In case of all other alkynes, ketone is formed. You can write Hg2 plus also H plus at 333. So Hg2 plus means HgSO4, H plus means H2SO4. So it will form ketone. Same isomerism way, the final product I have written propanol. If you want to understand how the second reaction occurs, so you just write down like this: CH3C, put a double bond. Here you put a negative charge, here you put a positive charge, because this is methyl group, this is electron repelling group, so this will shift here. Now H plus OH minus, so this OH minus will attack here, so it will become CH3 COH CH2. Now what will happen? Just let me give you the mechanistic part. These will shift here. This has two lone pair. This will shift here. This will shift here, and finally this proton will be attached to the CH2 minus group. So it will convert to CH3C. There will be a double bond, and this will become CH3. This is called keto form. That is propanone, and this is called enol form. So this is keto-enol tautomerism. So very important reaction.
Noted, sir.
Yeah. So now last reaction, we are moving into the last reaction, polymerization reactions. Polymerization. So one of the most important polymerization reaction of ethyne is that it reacts with 3 moles in presence of red hot copper tube. Red hot copper tube or red hot iron tube at 873 Kelvin. So it undergoes trimerization to form benzene. To form benzene, this is the conversion from aliphatic to aromatic. So how you can understand this reaction? Very easy to understand. Draw 3 ethyne molecules. What happens? This bond shift here, this bond shift here, this bond shift here. So triple bond gets converted to double bond, so it becomes double bond alternate. So this form benzene. So it is the conversion from aliphatic to aromatic. So benzene is a parent aromatic compound that you know. It is a very special compound, and it is used to synthesize a lot of different compounds like nitrobenzene, aniline, benzene diazenyl chloride, some dyes, drugs, large number of other organic compounds. And it also forms benzene diazenyl chloride, which actually forms some dyes through coupling reaction. So benzene can be used to synthesize dyes, drugs, and large number of other organic compounds. Large number of other organic compounds. So it is the parent aromatic compound. It is the parent aromatic compound.
Copied, sir.
Now, linear polymerization also, this is cyclic polymerization. It also undergo linear polymerization. So keep in mind that linear polymerization, it forms polyacetylene, and polyacetylene is used, it is conducting polymer. It is a conducting polymer. So when acetylene is polymerized, then it finally forms polyacetylene. It forms polyacetylene. This polyacetylene is a conducting polymer. So that is something, conducting polymer. So polyacetylene is a organically conducting polymer, organic conducting polymer. So this film of this polyacetylene can be used as electrodes in battery. So used as electrodes. So this is very, very important. Electrodes in battery. And it is cheaper than metal catalyst, and it is cheaper. So cheaper than metal catalyst. So I hope students, you understood properly